G'day and welcome to the second video on the gradient applications. And the first video we looked at distance and speed and time and all those sorts of things. And this time we're going to look at filling up different containers with water and looking at the rates at which they fill up. Okay, so we've got here three different types of containers, and we're going to assume that we're pouring the same amount of liquid into each of them. It really doesn't matter about the specifics of this. It's more just getting the general idea of what's going on. So each of the following containers are filled to the top with water, and what I'm going to do is I'm going to suggest a graph that describes the height of the water compared to time. So as the water is going into this here, it's going to increase the height of this overall of the water in the container, and what I want to do is I want to map this height as time goes on. Okay, and I'll do the same thing for all of them. The first one's probably the easiest one to see because the height will actually be a fairly constant rate of change. It's a consistent shape from top to bottom, so therefore the water going in, assuming that the water is going in at a constant rate, which is what we're assuming for all of them, then the height will just increase throughout the whole time fairly steadily. So if we're going to have a look at here, I won't call that y, I'll actually call that height, and I won't call that x, I'll call that time. It'll start at 0, the height will be 0, and by the end of it the height will be up to the top, which we'll just say is up there. And what's happening in between those two things is it's actually just a straight line. That was going to be a straight line, there we go. Because there's no real sort of changes to it, the height will just gradually increase moment by moment until it reaches the top. So that's the kind of graph that we would do to have the height and the time compared. Whereas if you have a look at this one here, it's not actually linear in this case, and we're sort of deviating a little bit from the topic because they're not linear relationships anymore. These ones will be a different kind of relationship, which I won't get into, but hopefully you can see what's going on. This part up here is going to, once the water reaches that point there, then the water is actually the height is actually going to increase at a constant rate, just like we had in the first example. That's going to increase at a constant rate there. However, from the bottom, we're actually going to see that the height is not going to increase at a constant rate, because you put in a bit of water at the start and the height will increase a little bit, but not as much as it will when it's, say, up here. The height is actually going to it's going to increase faster the higher that it gets. So we end up getting something similar to this, and it doesn't have to be exact. I just wanted you to kind of get an idea. It's actually going to be fairly, I'll do this in a different color. It's actually going to be fairly slow at the start, and it's going to sort of get faster. The height is actually going to increase quicker as it's going along. Now, I don't actually really know how to compare these two things. All I'm really interested in is the shape. Okay, so I'm not really interested in as to whether one fills up quicker or not, because I actually don't know enough information. I actually don't know the total capacity of each of these different things, but I'm just looking at the shape, the way that it increases. So the height actually goes, it starts off fairly slow. It's a gradual increase, but then it gets to a point where all of a sudden the height is increasing really, really quickly, and then it starts to be at a constant rate again as well. So that part there is straight, whereas all of that part there is a little bit curved. Now again, all I'm asking you to do is to sort of identify what's going on. You don't really need to know a lot about the curved lines in this in Year 9 anyway. Okay, so then I'll go to the third one over here, and this one is even more complicated. We can see from this point here up to this point here, it's going to be a constant rate that the height is going to increase by. Okay, so that bit there will be very similar to our first one and this part of the second one. But what about what's happening down here? Well, as we can see here, the height is actually going to increase, and for probably the first part of it, from there to there, say, the height's actually going to get slower, or the increase in height is actually going to get slower, because it takes more water and more water and more water to fill this part here. But then from this part here to this part here, so sort of halfway-ish, it's actually going to start to get quicker again, similar to the concept in the second one that we did, because you actually need less water to increase the height. So this one is going to be a little bit crazy. So for this one, although the height is actually increasing, the rate at which the height is increasing is actually getting slower. So it probably does something a little bit like that. And then all of a sudden, it starts to get quicker again, like this. And then it has a big long stretch of straight. So let's just say that that part there is straight. So it kind of does a little bit of this curve there. Now again, I'm not really interested in the accuracy of these graphs because I don't know the capacity of each container. I don't really know much about this at all. I'm just looking at the way that that each of them would fill up. So the heights compared to the time of each of these. So hopefully that's made a little bit of sense. You can also utilize the videos on MathSpace if you want some further help. But otherwise, enjoy doing the MathSpace tasks. Thanks.